7.3 and 7.4, the sine, cosine, and tangent ratios. So what we're doing here is for right-angled triangles, we can use three primary trigonometric ratios to help us solve a triangle. Now, solving a triangle means that we need to look at the angles and the sides. In fact, it means for us to find all the values of the, find the measures of all the sides and the angles. And we're going to see an example of that in this section. Now, to use trig ratios, trig is the short form for trigonometric. So, to use trigonometric ratios, you must have a right triangle with two pieces of additional information. Those two pieces include two sides or one side and another angle, not the 90-degree angle. We need that to be able to solve the problems. So, depending on what is given, you will determine which ratio to use. So here we go with a right triangle. Note the way this triangle is drawn. We could look at any type of right triangle in any direction. So I'm just going to show you a typical right angle triangle is drawn as such. We take it and we draw it, and we usually draw it up like this. Or we draw it up like this. Or folks, sometimes we have it drawn like this. But most of the time we don't have some weird drawing of the triangle. Okay? Now, when we have these triangles, what's important to note is what the right angle does. This right angle here points to a side. What side does it point to? That's right, the hypotenuse. So we're going to look at information regarding this. Sohcahtoa is the short form to remember the mnemonic, or the what we call the acronym to remember all the trig ratios. Now note the way it's written. It's written like this because it exemplifies the major letters, which are S, C, and T, which stand for sine, cosine, and tangent, just like the title. And the O and the H and the A represent the proportion that you're going to use. So similar triangles plays a factor in being able to prove trigonometric ratios. At this point in time, we're just going to use it. So, make sure, for example, that your calculator is always in degree mode. So check your calculator now to ensure that you have either a D or a DEG on your calculator screen. Now, because of that, we need to be able to fill in the information. We need degrees because our information will always have a degree of some sort. So, given a triangle, a right triangle as such, and let's say we're looking at A. So we always mark the A. That mark was not there before. It looked like that, and you always, always, always mark the angle. Why do we mark the angle? Because it helps us identify the proper sides. That mark touches two sides. One is up here, and one is over here. We all know what this side is. Well, that's because the right angle points to that side. That side is known as the hypotenuse. Now, the other side, the marked angle touches, is always going to be the adjacent side, because adjacent means next to. It is next to the marked angle. It is next to the angle A. It is beside. Now, some of you are going, but wait, the hypotenuse is also beside. Wait, remember that the right angle points to the hypotenuse. That already has a special name. So, what is the third side known as? Well, it is directly across from A. And that means that that is the opposite side. So it is opposite the angle that we're looking at. Because of that, we can set up our ratios. Sine, now note that if I had marked this angle What changes are the opposite and the adjacent. What doesn't change is the hypotenuse. The hypotenuse is always opposite the right angle. So I had marked this side, which is in green. Now this is still the hypotenuse, but this side is now the adjacent side because it's depending on the marked angle. And the opposite to that is over here, so that's the opposite side. The hypotenuse stays the hypotenuse because the triangle actually didn't move. What we changed was from the angle perspective. Okay, so sine of angle A is equal to opposite over hypotenuse. Cosine of angle A is equal to adjacent over hypotenuse. And tangent of angle A is equal to opposite over adjacent. What's important to note here is all of these values are not called sin, cos, and tan, but actually sine, cosine, and tangent. And in Catholic school, they had the running joke in math was that it's a sin to say sin in math. So we don't forget, folks. It is important that that you use the proper terminology. So it's sine, cosine, and tangent, and these are the ratios. We're going to use these ratios to be able to solve our problems. All right, first example. Before we do any of the harder ones, we're going to go straight to a bunch of examples that I want you to be able to be familiar with your calculator. So we're going to look at all these examples here and be able to type this information in your calculator. So, how you're going to type in sine 45 if you have the new Funky Duty calculators. That's right, the calculators that are more recently created today, the right view, the natural display, things like that. Those calculators type this in exactly as you see it, as opposed to back in my old days. So sine of 45, you actually type that in your calculator. Most of your calculators will give you either 1 over root 2 or root 2 over 2. And those are acceptable exact answers, and I do want you to write them down. I don't care which one or the other. And then finally, I want you to give me the decimal version of it. So press the special button to change it, and that will give you 0.7071 approximately. All right. Sometimes we'll have an exact value, which we write. If we don't, we automatically use the decimal value, round to 4 decimal places, unless otherwise stated. So, tan of 20 degrees, folks, you should be getting this. And cosine of 60 degrees, you should get this. And note the dot over the equal sign means approximate. This is an exact value, so we do not put a dot here. All right, so these are all values. So if sorry, folks, sorry about that. These are all values that represent the ratios of those particular angles. The next part is interesting. What we have here is an angle, a side, and this would be the hypotenuse, but we need to find the adjacent side. So we're looking for this side. To do that, well, how do we solve this? We take cosine of 70 and put it over 1. Why do I put it over 1? That will allow me to cross multiply. I get 15 times cos 70 is equal to x. Now this is very important that you note this. Notice I haven't touched a calculator yet, and you shouldn't be. This should be simple math that you simplify before you type it in the calculator. The calculator is the very last step, which gives us a value of 5.1303 approximately. So the measure of that side, the adjacent side, is 5.1303. All right, tan 55. This, we put it over 1, and we cross multiply, and we get a value of x times tan 55 is equal to 8. What does that mean? Well, folks, that means we have an isolated for x. So now what we're going to have to do is move the tan 55, the whole thing over. So we have x is equal to 8 over tan 55. Type that in your calculator, 8 divided by tan 55, and you get x equals 5.6017. What's something neat to look for is that when you don't know the value on the top, we're actually going to multiply these two values that we know. If you don't know the value and it's on the bottom, we're going to divide. So it would be 8 divided by tan of 55. So the last one, is the x on the top or the bottom? That's right, it's on the bottom. So we're going to divide 5 divided by sine 75. And that's x is equal to that, which equals a value of 5.1764. So all three of these values, very important to know, is when you don't know when the unknown is on top, you're going to always multiply. When the unknown is on the bottom, you're always going to, and let's look at the example, it will always divide. Okay. Last one, what's going on here? Well, folks, we need to find the angle. To find an angle, if you look on your calculator, just above the button, onto the plastic of the actual calculator, you'll notice that it actually says sine with a -1. Well, that -1 actually doesn't mean -1. What it means is that is the sine inverse. So the sine inverse is when finding an angle, we always use the inverse, whether it be sine inverse, cos inverse, or tan inverse. We're always going to inverse to find the angle. So sine inverse of 0.8829 will give us a value of 61.9942 degrees. This is an angle, folks, so it will be in degrees. So it's in degree mode. The next one, A, is equal to cos inverse of 1/20. So we do not find the decimal version of this value. We actually use the exact value that you're given. So cos inverse of 1/20 is actually equal to 87.1340 degrees. Last one, tan A is equal to 0.0875. Take the inverse. A is equal to the tan inverse of that value. And that will give you a number of 5.0006 degrees. That's the last value there. Okay, moving forwards. Now let's look at a real example. Example number 2, you're asked to find sine theta, cos theta, tan theta for the following. Okay, so here we go. You're asked to find sine, cos, and tan of this triangle with theta indicated to you. What is the first step you need to do? Hopefully you're remembering that you must mark the angle first. So we're going to mark it just as such. And now that we marked it, we know what the sides are. For example, the right angle points to the hypotenuse. That's your hypotenuse. This side will be your adjacent side. And finally, this side will be your opposite side. So theta is used to represent an angle. Don't be afraid to use it. Sine theta is equal to 8/17. Cos theta is equal to 15/17. Note that I circled the hypotenuse. Sometimes students find it easy to circle the hypotenuse as soon as you're dealing with right angle triangles, and that's fine with me. So, last but not least, tan theta is equal to 8/15. Now, what we're going to do is just extend this by finding the values of theta. You only have to do what it says. We're extending it because just in case you have a question that asks that. So, if I did sine inverse of 8/17, I'm going to get 28.0725. If I take the cos inverse of 15/17, I'm going to get 28.0725. And then if I take the tan inverse of 8/15, I'm also going to get 28.0725. Why is that the case? That's right. Hopefully you're thinking, well, it better be the same value because this angle is the angle we're talking about. So you don't have to do all three to find the value of theta. You only need one of these. Any one of these would have found out that the angle is 28.0725. All right. Example 3. You're asked to find to the nearest degree the angle of inclination of the ramp. So here's your ramp. Now, very important to note the angle of inclination. A lot of students might think this is the angle of inclination, and that is wrong. An angle of inclination, depression, or elevation all has to do with a horizontal. From a horizontal, you either rise up to the angle or you fall down below. Never, never would it be this, because it is always from a horizontal. This being a horizontal line, it's from a horizontal. So this is the angle that we need to find. How are we going to find it? Well, what side is 1? That is the opposite. 12 is the adjacent. Remember where the hypotenuse is, it'd be over here. So, and the marked angle touches the opposite and the hypotenuse. Sorry, the adjacent and the hypotenuse. The opposite is way across the other side. So folks, we have the opposite, we have the adjacent. What uses opposite and adjacent? So there's Sohcahtoa. That's right, toa is the one we're going to use. Tangent of the angle, we're going to just call it theta, is equal to opposite over adjacent, which is 1 over 12. And we solve for theta by taking the tan inverse of 1 over 12, and that will give us a value for theta to be 4.7636 degrees. Therefore, the angle is 5 degrees. Notice I didn't round here in the question. I rounded to 4 decimal places, but in my final statement I got 5 degrees because I go back and read the question and reread the question. It says find the nearest degree. So we rounded to the nearest degree in the final statement. All right, moving forwards. Example number 4. Determine the value of x to the nearest centimeter. So here's our x and here's our values here. Okay, that's all you're given. We need to find x. So we have our marked angle. What side is 15 with respect to our marked angle? That's right, hopefully you're thinking the adjacent, and x is directly opposite the 32. Now, before we do that, let me show you example number 5 so that you have both. And we're going to go back and answer the first one in example 4. So this side is the opposite, and this side is the adjacent. So we label them, and we're going to use tangent because that gives us toa. Tangent of 32 is equal to x over 15, opposite over adjacent. And we get x is equal to 15 times tan 32, which gives us a grand sum total of 9.3730. So therefore, x is close to 9 centimeters long. All right, example number 5. You might be thinking, where's side B? I don't see a B here. Well, I want you to think of the big letter as the angle as being the parent. The parent always looks after the children. The children looks across over to the children. So this side, folks, that's right, is little b. We have little b. This one would be known as little c, and this one would be known as little a. Another important thing is mark your angle because we know what it touches. And we have 11 is our hypotenuse, b is our opposite. What uses opposite and hypotenuse? That's right, it is so. So sine of 37 is equal to b over 11. Solve by multiplying because the unknown is on top, and we get 6.6200 units. The units is centimeters. Our final statement is going to be, therefore, side B is equal to 6.6200 centimeters. And yes, you need those zeros. So one more time. Therefore, little b is 6.6200 centimeters. And that's the final statement here. All right, let's look at 2 word problems. The first one is as follows, where it says, a wire 17 meters long was attached from the top of a 15-meter high radio antenna to the ground. Determine the angle between the wire and the ground and the distance from the base of the antenna to where the wire is attached to the ground. Alright, so we need some information to draw this out. So wire 17 meters long is attached from the top of a 15-meter high tower radio antenna to the ground. Alright, so we're going to draw this. Here's my radio antenna. And I know I have a wire. Let's color the wire black. And we have a wire coming across and touching the ground. And the ground being green. Alright. So we know that this wire is exactly 17 meters long. And we do know from the top of a 15-meter high radio tower, and you know that it's a right angle. Every tower to the ground should be assumed, or can be assumed, one of the few things, that it's definitely 90 degrees. And we need to find the angle between the wire and the ground. Which one is the wire and the ground? Well, this is the tower, this is the wire, so this is the angle between the tower and the wire, and this here is between the wire and the ground, so we need to find that angle. So that is the angle we're looking for right here. Well, what are we going to use to find the value? Well, we need this value, this is opposite, and this is the hypotenuse. What uses opposite and hypotenuse? That's right, it will be sine. So we set it up. Sine of angle, well, let's call it angle theta, is equal to 15 over 17 to find the value of that. So theta is equal to the sine inverse of 15 over 17. And the sine inverse of 15 over 17, hopefully you're typing it into your calculator, theta will equal 61.9275 degrees. So we know the angle that the wire makes with the ground, so we've answered that. So that part is correct, is done. And then it says, and the distance from the base of the antenna to where the wire is attached to the ground. Well, where is that? Well, if you look carefully, the distance from the wires attached to the ground to the base of the antenna means that we're looking at from here to here. So we need to know, that's right, the measurement from here to here. And we need to know that. So let's call that x. Well, to do that, we can either use Pythagorean Theorem with the information we're given, or we use the theta value to find it. I highly recommend that you consider using what you're given. Always try to do that first. Since you're given two sides and a right angle, you can find the third side using Pythagorean Theorem. So x squared is going to equal x squared is going to equal 17 squared minus 15 squared. Well, to get rid of the square, we have to square root. So we're going to square root these values, and that will give us a number of 8. The square root 17 squared minus 15 squared is equal to 64. Square root of 64 is 8. So now we have that answer, and we've answered all the questions in the problem, so we can do a therefore. Therefore, the wire makes with the ground an angle of 61.9275 degrees, and the distance from the wire to the antenna is 8 meters. All right, that's the end of that lesson. Let's move on to the next one, the next example. Here we go. And this is our last problem. You're asked here in example 7 to solve for triangle XYZ. You're asked to round side lengths to the nearest meter and angles to the nearest degree. What I recommend that you do right now is stop the video and try this question by yourself. When you're ready, you can start the video again. Stop now. Okay, so when you're asked to solve, you should automatically do the following. List all the sides, which are x, y, and z, little ones, remember? X is equivalent to yz, just in case you're not sure which one it is. Y is equal to xz, and finally z is equal to xy. All right, and these values we need to fill in if we know them already. We know yx, or xy, and that's 13.3 meters. That's our little z. We know also xz, which is our hypotenuse, which is 19 meters. So we only need yz to find out. Also, we need to know all the angles. So list all the angles. There is angle x, angle y, and angle z. What are those values? Possibly those that we already have that we don't need to repeat. And those would be angle y, which is 90 degrees. The other ones will be degrees, but we don't know what they'll be. This here is the final statement box that you're going to fit in all of the required information. So angle x we need to find. So let's show some work for this. Angle x we're going to mark. Once we mark it, we can now determine information. For example, 19 is our hypotenuse. 13.3 is our adjacent side. So what do we have here with adjacent and hypotenuse? We have the cosine. Cosine of that angle x is equal to adjacent over hypotenuse, which is 13.3 over 19. X is equal to the cosinverse of 13.3 over 19. And using your calculator, you should be able to find that value. Okay, the angle is equal to 45.5730 degrees. Once I know that, I can fill that information in. So inside angle x is going to be 45.5730, and again that's degrees. We can find the third angle, the missing angle, angle z, by literally just using the sum of the angles in a triangle theorem. Sum of the angles in a triangle theorem says z will equal 180 minus 90 minus the 45.5730. 0.5730. And that will result in an answer of 44.4270 degrees. So that's in degrees. That's z. So now we have that value. So we fill it in. For z, 44. Now remember we need to round the angles to the nearest degree. So we had 45.5. We could write 46 here. And then the other angle is going to be an angle of just 44 degrees. That is the remaining. Okay, so this uses, again one more time, that is the theorem that says sum of the angles in a triangle theorem. Sum angle triangle theorem, SATT for short, telling you that all the angles in a triangle equals 180 degrees. We have one more thing to do, and that is to find side x. Well, you know it's a right angle triangle and we have two sides. We can find the third side using Pythagorean Theorem. I'm going to just pause the video here to give you some chance to be able to complete this last section. Okay, so The final part is finding the value of x, and that is by using Pythagorean Theorem. X is equal to, using Pythagorean Theorem, 19 squared minus 13.3 squared, and that's the square root of that. That means that x is equal to 13.5687, which is almost 14 meters. So what we have here is all the sides and all the angles listed, and that allows us to solve our triangle. Alright folks, that's the end of the video. Take care. Have a numerical day.